and that would be it. So President Dinesh, I hand it over to you.
Thank you, John.
Welcome.
So I'm very pleased to call the meeting to order. As John said that you have to unmute, but mute, but you please unmute when we ask you. There will be 2 occasions during the meeting when we'll ask you to unmute. Thank you. Honorary member Bhagwan, Pak Mohan, Shifang, right. Past presidents, fellow Rotarians, distinguished guests. And we also have some spouses. Welcome, Uma. Very good evening and warm welcome to our 17th Rotary meeting today. It's my pleasure to welcome our speaker, Professor Jeff Obard. He's founder of Living Planet consultancy firm, who will speak on a very hot topic, climate change. Can we avoid hothouse Earth? Thank you, Professor Jeff, for speaking to us today. I don't spot any visiting Rotarian. Well, once again, I would like to welcome all our guests, and some of them are our prospective members who would like to join our club. Thank you for coming, and enjoy the evening with us. Now I would like to call upon Rotarian Jasbir Kaur to raise the toast to our great institution, Rotary International. Jess, please.
Hi, everyone. Please get your glasses ready. Okay, fellow Rotarians, can I see your glasses, please? All right, please join me in the toast to the Rotary International.
Rotary International.
Rotary International. Rotary International.
Rotary International.
Thank you, Jess. I would like to share my screen.
You can, you're a co-host.
Thank you. All right. May I call upon Honorary Secretary for Club Announcements? Bridget, please.
Yes, thank you, President Dinesh. There's only one announcement to let you know about the regular committee meeting. Tomorrow is the Vocational Service Committee meeting hosted by Dr. Chan, 7 o'clock on Zoom as usual. That is the announcement for this week for me today.
Thank you, Bridget. I think now we have some birthdays, or we have 2 birthday celebrants whose birthday is today. Louisa Lee and past President Ellen Tan. Both of them are enjoying or celebrating their birthday with the families. Ellen Tan has asked, PP Ellen has asked me to convey best wishes to all of you. So I spoke to both of them. I sent them a message. Wedding anniversary, best wishes to wedding anniversary celebrants this week. We have Chongzi Cheng and Lulu, 11th November. That's today. Kizo and Mayumi Fujitake, 13th of November. Vineet and Tejali Sarangdhar, 17th November. Wish you all very happy wedding anniversary. Enjoy. Thank you. Okay. Congratulations to our Honorary Secretary, Bridget. She becomes our newest Paul Harris Fellow. Thank you, Bridget, for your contribution, and you become the Paul Harris Fellow today. Thank you. And now I'm very pleased to make another very important announcement. And that is nomination of the president for the year 2022-23. Nomination committee has unanimously nominated or recommended the nomination of our Rotarian Louis Lim to be the president of the Rotary Club of Singapore for the year 2022-23.
Congrats, Louis.
Congratulations, Louis.
Congratulations.
Louis.
But that's a nomination.
Oh.
We also gave a notice of nominations and notice for the position of president of the Rotary Club for year 22-23 by the members from the floor. If you have another candidate, this is to be submitted to our honorary secretary with proposer, seconder, with the consent of the candidate. This nomination will close at 12 p.m. on 30th November 2020. The adoption of the nominations will be at the AGM on 16 December 2020. So on 16 December, we'll have the president nominee who will be the president for the year 2022-23. Next, I'm very, very pleased to induct a new member to our Rotary family. And he is Mr. Ranganathan Somanathan. Many of you know him very well. He has been attending our meetings. He has been attending our Jolly Walk on Sundays. And today it's my pleasure to induct him. Fellow Rotarians, it is my pleasure today to welcome into our membership Mr. Ranganathan Somanathan. The proposal has been reviewed in accordance with the Constitution and the bylaws of the club. I will now ask Vice President Suresh Kirti to introduce him. His proposer is none other than Honorary Secretary Rotarian Bridget. Suresh, please.
Thank you, President. It's my pleasure to introduce another candidate, a wonderful candidate for induction today. He is none other than Ranganathan Somanathan. He is the CEO of Omnicom, which is a global media and advertising company. He's an expert in media, communications, a thought leader in digital marketing. He's worked in India, Japan, Malaysia, and Singapore. He's married to Uma, and an e-commerce entrepreneur and a volunteer, blessed with 2 children. And as President mentioned, everybody knows him because we have seen him in projects, on the meetings, and in fellowship. Welcome, Ranganathan. Thank you.
Thank you, VP Suresh.
So his classification is media specialist, sorry.
Yeah. I now ask Ranga, as you would like to be known in the club, we now proceed to admit you into membership in the Rotary Club of Singapore. You have been chosen for membership in this club because your fellow members believe in you to be a leader in your field and have qualities which will allow you to carry out the work of a Rotarian. In electing you to the membership, we are doing more than taking you into our fellowship. We are making you a trustee with us of the Rotary ideals. Knowing you to be a Rotarian, the world will henceforth judge Rotary by your conduct. Membership in the Rotary is an honor and privilege, and every privilege has its corresponding obligations. You have agreed to accept the responsibilities attached to your membership in this club and to obey this club's constitution and bylaws. One of the special obligations of the membership is regular attendance at the weekly meetings and monthly service committee meetings and participation in club projects and activities. It is the primary method of fulfilling the principles of service and fellowship, and also a way by which you represent your vocation. Ranga, the ideal of Rotary is service. Our principal motto is service above self. And the object of this club and all Rotary clubs is to encourage and foster this ideal of the basis of worthy enterprise. You are to share in this effort for the rest of this Rotary year. I would be pleased if you would serve on the VSC Vocational Service Committee. You may also join other service committees. I will also recommend you to join Rotary Image and PR Club Committee to utilize your vocation in the club activities. Your mentor is your proposer, Honorary Secretary Bridget, who will guide you in assimilation through the service committees. Ranga, your classification is advertising media specialist. As you represent a classification, it is your duty to tell us about your vocation and to bring the ideals of the Rotary to your business and profession. And now, by the power vested in me as President of the Rotary Club of Singapore, I declare you to be an active member of this Rotary Club. I'll present you with a Rotary emblem and a packet of Rotary literature at a later date. I especially commend to your attention the object of Rotary and the four-way test, which form the criteria for Rotarians in their daily lives. I also suggest that as you travel, you avail yourself of the extraordinary opportunity you will have to attend Rotary meetings and meet Rotarians throughout the world. This is another extremely rewarding benefit of your membership. Fellow Rotarians, I'm happy to present to you Rotarian Ranga, our newest member. Could you please unmute yourself and let us welcome Ranga with a round of applause.
Congratulations.
Congrats.
Congratulations.
Yeah, yeah. Welcome, Ranga.
Thank you.
Welcome.
Thank you.
Congratulations,
Thank you.
Welcome.
husband and wife.
We welcome you, Ranga, to the oldest Rotary Club in the district 3310, the Rotary Club of Singapore. Welcome to the Rotary. We look forward to the enrichment of our lives as well, that of yours, by your association in this, the world's oldest, largest, and the finest service organization. I would now like to invite Rotarian Ranga to briefly address the club. Ranga, please.
Thank you, President Dinesh. Good evening, everyone. It's an honor to be inducted into the Rotary Club of Singapore. Thank you, Vice President Suresh, for reaching out, Honorary Secretary Bridget for nominating me and also being my mentor, and Past President Mohan Das for the orientation. The journey has been amazing. It has been an amazing experience to be part of the setup, to eradicate the polio step-up challenge, the weekly fellowship walks, and the Wednesday fellowship meetings, as well as the service meetings that I've managed to attend on Thursdays. So I very much look forward to resume the walks when I return back to Singapore. I very much miss that when I'm here and connecting from Mumbai. My first encounter with Rotary happened in the mid-90s. thanks to my mentor, late Dr. N.H. Atreya, who was a very active Rotarian in the Rotary Club of Mumbai. If my records are right, he was a Rotary member from 60s, 70s, 80s, and then I met him in mid-90s. He recently passed away. As life took me on a journey since my encounter with Dr. Atreya, I lived in, I moved from Mumbai to Bangalore, to Dhaka, to KL, to Tokyo, to Jakarta, and then, Singapore has been our longest base in a while. And it has always been in the back of my head to become part of the fellowship. But thanks to the nudge from Vice President Suresh, the stars aligned, and I'm excited to be inducted into the Rotary Club. Thank you once again for the honor. Personally, service leadership has been my motto. Leading organizations in the corporate world, that has been my approach. Putting people first, helping them, enabling them to realize their potential. And the Rotary's service above self motto connects with me at my core. And I look forward to actively serving and supporting the initiatives of the Rotary Club of Singapore. Working for the community betterment is something that is close to my life partner, Uma. She has been an active volunteer with Project Smile, a Singapore-based NGO, supporting and motivating individual ladies with empowerment. Allow me to also introduce my wife, Uma Ranganathan. Uma, I want to jump in and say hi and introduce yourself.
Yeah, sure. Thank you once again for having me join this meeting. I think it's an honor which Ranga will really cherish. This being a part of Rotary Club, and like you said, it's been something that he has been thinking about for a while. Thanks largely to his first interaction with Dr. Atreya, and having sort of like had such a close watch on what Rotarians do. Over the past few months, I know that he has made a special effort to really be a part of it. Has joined the walks, and he has taken my son along as well, who also, by the way, has really enjoyed the Sunday morning walks, though he had to wake up a little early, but it seems to have been worth it at the end of the walk, the roti canai and the sort of like the breakfast that you all sort of like treated him to. So, like I said, delighted to be here. And a little bit about myself. My background is also in media. I started off my career in media, and then after taking a short break to have my children when they were very young, I took a short break and then moved on to run my own e-commerce business. And then from then on, I currently work in the e-commerce space. Like Ranga mentioned, I also volunteer with an organization here, which is a charity based out of Singapore, supporting single moms from low-income families. So I try to do the best that I can in that particular role, and along with the work, I juggle the three things, and I'll be very happy to support Ranga in his endeavors with Rotary, and participate in initiatives that the Rotary Club takes as well, to the best of my capability, and I look forward to doing that. Thank you.
Thank you. Thank you.
President Dinesh, I'll sign off by saying that we are really excited as a family. We are proud parents of Akshat and Anindita, who are pursuing their passion in music, even as they're working towards academic excellence, and hopefully get them involved in the Rotary family in their respective segments. So thanks again, once again, for the warm welcome. It's an honor, it's a privilege, and hopefully we'll live up to the responsibilities. Thank you very much.
Thank you, Rotary Ranga. We welcome your family to the Rotary family. And thank you, Uma. I'll introduce you to the First Lady, Rekha, for the spouse programs. Thank you.
Thank you very much.
And now we have our next program. You know very well, Know Your Fellow Rotarian is Kaifer. And today on Kaifer is our very new Rotarian. He's very new, but he's not really very new, because he has rejoined our club. He was a member of a club for a couple of years. Well, let him tell about himself and fellow Rotarians, and the guests. Our Kaifer member today is none other than Rotarian Nirmal Singh, who joined just last month. I'm very pleased to give you Nirmal.
All right.
I'll stop sharing.
Yep.
Yeah.
Are you able to see my screen?
Yeah.
Yes.
You just need to
The fonts are very light.
click on the full slide.
Yeah.
Yeah.
Right.
Yeah.
Right. So I thought this was a great initiative from President Dinesh to know your fellow Rotarian. My wife has also just joined me, so yeah. Through this, not only the fellow Rotarians know who the other Rotarians are, but also what they are. And it's a great initiative. So I thought just to add a bit of humor, I'll start telling from the time I was born, why, where, and how. But then my wife told me that who cares? So I don't need to talk about my birth. So I'll skip the first 20 years of my life. As we all know, miracles do happen. So I just move on to the right. So I start with the my graduation. I'm a commerce graduate from the one of the most prestigious college in Bombay, in India. In fact, Sydenham College of Commerce. I'm from the 80s batch. I finished my chartered accountancy in 1983, and in the same year, I also accomplished the Cost and Works accountancy from Institute of Cost and Works Accountants in India. Going on to my career, in 1988, I was admitted as a partner in one of the oldest, well-renowned mid-size firm of chartered accountants in India, the firm called N.M. Rajan Company. I was there as a partner from 88 to 95. As you can see from the picture, are the founders and his son, who are no longer obviously around, but with Jamshedji Tata. So we were the house auditors for Tatas and some of the very well-known industrial house in India. In 95, I wanted to test the waters on the other side, and that's when we moved to Singapore in late 95 to join this company called Micros. I joined as the Chief Financial Officer for Asia Pacific region, and this company was the leading IT provider for hospitality industry. And when we say hospitality, that's the hotels, restaurants, retail, and so on, and which is why my category is hospitality industry, IT hospitality industry, because I spent all my life in the hospitality. And I said was because this company was acquired in 2014 June by Oracle, and I continued with the new company for about a year as the president for Asia Pacific. And that's when I took a sabbatical for 2.5 years. I did everything that I like to do. I traveled around, did everything that I'd been wanting to do in Indian case. You'll see that later. And then recently I decided to come back to the corporate world. I joined a company called Shiji, which is substantially in the same business as my previous two companies, or I say two companies because it's Micros and Oracle. But now I've joined as the global CFO, and I'm also responsible for legal affairs and human resources. I've traveled quite a bit, but as you can see, there's still a lot to travel. Good parts of the world that I've not yet been to. Then talking about my other activities, my other interests, I did manage to get up to the Everest Base Camp in April 2017 with a bunch of few friends, some from Singapore, some from India, some from Nepal. We reached the base camp on the 9th day. We should have reached on the 8th day, but two of the members were hit by the high altitude syndrome, so we had to delay by a day. I walk a lot, and one of the milestones I completed recently in November 2019 was a 50-kilometer walk in Singapore by this charity organization called Let's Take a Walk. So I accomplished that. It was quite painful, but it was very fulfilling at the end of the trip. Amongst other things, of course, I cycle a lot. That's my passion. Nothing less than 50 kilometers any time. This picture is taken when I did the first time 100 kilometers without dismounting from the bike. So non-stop, I did 100K round bike. And of course, I consider golfing to be my lifestyle. I enjoy golfing wherever I can. In the current situation, it's harder to pursue that interest. I got married in 1993 with my lovely wife, and she's here with me. That was February 14th. That's Valentine's Day. And somebody will ask whether I chose that day deliberately, because I would never forget the anniversary. And I'm very proud to say that ours was an arranged marriage, and you know, some might see that as a surprise, but I'm very proud to say it's an institution that we all respect, and ours was the arranged marriage. And I think we first married and then fell in love, and here we are after a good 27, 28 years, and that's how we look today. This is my family. I'm blessed with 2 children. This is one of the many holidays that we took. My daughter is Nanika. She's 26. She's an NUS graduate in political science, and then she worked for some time, and then recently she completed a master's from University of Edinburgh in international development, and she just came back, completed her 2 weeks of quarantine in a hotel, and now she's looking for a job here in Singapore or elsewhere. My son is 21, and we are Singaporeans. All of us took up the Singapore citizenship in 2002, and Rohin just completed his national service. He achieved his ORD in November 2020, and because he cannot start his academic year immediately, he can only start next year. So he's at the moment interning in a multifamily office here in Singapore, and he's just taken on to the interest in the wealth management, financial planning, and so on. Surprise, surprise, I don't know where he gets that interest from. Besides these activities, I also am involved in some of the other charity activities. I chair a foundation called Lotus Life Foundation. It's a Singapore domicile foundation. It's a grant-making foundation, which was set up in around 2017. We have quite a few programs here. We are partnered with NUS. We set up a bursary for the medical students, where we provide the complete tuition fee and the living allowance for the entire 4 or 5 years of their tenure in NUS. So we've been, we set up that fund. The other one is the Lotus NUS Fund, which is basically to encourage the social entrepreneurship amongst the Singapore citizens. So this was a fund that we set up where every year we selected up to 5 awardees, and we awarded $25,000 each for them to take the idea off the drawing board to an audition stage. And I think over the years we funded about 15 of such startups. Besides that, we also contributed to what is known as the Lotus NUH Healthcare Innovation Fund, basically to encourage the medical under and postgraduates here in Singapore. That was a program we started last year. Besides that, we also set up a bursary in Taman Jurong constituency. We set up a bursary for the needy students in that constituency. The second institution that we work with is SMU, and it's called the Social SMS Lotus Initiative. We have kind of taken up a village in the northeast part of Nepal. It's in a district called Dankuta, and the village is called, the Nepalese name is Shahid Bhumi, which is martyrs' land. There's some history to that, but since I have limited 7 minutes, I won't talk much about it. But it's one of the one of the poorest village in that district, and we have taken up the challenge to uplift about 18,000 population in that village above the poverty line over 5 years. And this is not by giving them the money, but this is to create kind of an ecosystem to promote the activity within the village. As we all know, the problems that are faced in the villages where the youngsters leave the village and the elders are left behind, and so on. It's not the something that they are in the occupation for all 12 months of the year. So that's the program, very ambitious program, and we started that with NHCMU. Besides that, we also work with a foundation in Nepal. As you can see, obviously a lot of people know about my lineage, and we have deep roots in Nepal. We have deep interest in Nepal. There's another foundation in Nepal that we work with, and through this foundation, we provide the assistance in microfinancing to largely women entrepreneurs. There's a certain category that criteria that the women have to satisfy, but that's been a very successful program. So just to end, I just wanted to say, obviously, to all of us, I think giving comes very naturally. We all like to give. The degree varies. Some give in terms of time, kind, some give in terms of money. But I think in my mind, and I feel that I'll share one anecdote with you if the time allows, but it's important to know whom to give. The anecdote that I want to share very briefly, it's a long, funny story that recently I was in Europe. I was driving back with another colleague of mine from Croatia, all the way from Croatia up to Poland, about 10 hours drive. And we were driving a German plated car, and we were trying to close a deal, selling off a company in US. And then we were on the call with buyers. We pulled at a gas station. And then another German plated car drove next to us, and the guy very wildly gesticulated towards us, and we rolled down the window, and he said that he's in desperate need of money. He has to drive all the way to Germany, and he wanted some money. We were on the call, and then we started to think that ask him to come to my side. I was driving at that time. I rolled down the window. We gave him €50. And he was not happy. He said, I wanted more money. And, so he asked for some more money. And then we gave some more money to him. And he said, no, I want some more money. And he started giving his gold ring, a finger ring. He dropped it on my lap. I said, I don't want it. I gave it back to him. And he said, no, take this ring. I want more money. I really have to take this family back to Germany. And then he took another ring. And then in the process, then he took out his gold bracelet. And then he wanted some more money. He gave him some more money. And they said, no, can you give me some more money? I give you my gold chain also. And he dropped gold chain, gold bracelet, gold rings in my lap. And we gave him up to €300. And then he wanted some more money. And I said, no, I think that's it. Go away. We don't want this gold. He said, no, take it. This is worth thousands of dollars. But, thank you for helping me. And he drove off. We finished the call. We drove off. And, of course, after we reached Poland, we wanted to check whether this was real gold, and as you all can guess, it was aluminium. So in our desire to help this guy who seemingly looked a needy person at that point in time, we gave him money, but he cheated us out of €300. So that's why I said I learned the lesson. Giving is natural, but you have to also understand whom to give, and that's very important. And so I wanted to end here, but thank you.
Thank you, Nirmal. Thank you.
Thank you, Nirmal.
Thank you.
Yes, it's a Rotary month. It's a month of giving, and nice to know all your programs helping people. Thank you very much. And
can you stop sharing now, Nirmal?
Yeah, Nirmal.
Yeah. Can you
just stop share your screen?
There is some noise from somewhere.
No, I think it's fine.
Yeah, I think I don't share anymore. Yeah.
Okay, perfect.
I would like to welcome the spouses. I see Mamta here, a spouse of Mukund. Rajni, welcome. And Lakshmi, warm welcome. See you. And we have Rekha, First Lady, this on the second screen, and all other spouses, if I'm not able to spot, and I was told by Rekha there are many others joining today. Thank you all, and I welcome you all. So I'll just share my screen. Yes, please. Perhaps.
Good to know you, Rotary Nirmal. Thank you for that wonderful presentation.
Well, I'm not able to change this.
Can we now move to the speaker?
Yeah. No, we'll move to. Now I have to stop this. Don't mind. All right, so this is speaker time, and our speaker today is Jeff Hobart. But before I call him, and I like to call Rotarian Louis to introduce him. Rotarian Louis, please.
Hi, fellow Rotarians. Professor Jeff Hobart holds a PhD in environmental science and bachelor degree in ecology, first class, from the United Kingdom. Jeff spent 17 years of his career at the Faculty of Engineering at the National University of Singapore and has recently returned to Singapore from Qatar University, where he was director professor of its Environmental Science Center. During his time in US, he was a director of the Sustainable Development and Water Alliance and research director at the Tropical Marine Science Institute. Jeff has worked in the US with Shell Petroleum and in Hong Kong and the UK as private sector environmental consultant. He is currently a visiting professor to the School of Water, Energy and Environment at the Cranfield University in the UK, and recently founded the company Live and Planet in Singapore to provide consultant service on the climate change, sustainability and environment. Has conducted projects throughout Southeast Asia, as well as China and India. He is an expert reviewer to the Intergovernmental Panel of Climate Change and serves as the climate change advisor to the National Youth Council in Singapore. With no further ado, I present you Professor Jeff Hobart. Professor, I think you are in mute.
We can't hear you, Professor. Jeff, can you unmute yourself? Let's see. We can't hear you.
Perhaps JK can, okay, he's been muted.
Yeah. What to do? We should have tested the audio before.
Anybody call him?
Yeah.
Hello? Is that Shanta?
He's not answering. I don't really know what to do. Jeff, do you want to sort of log out again and then log on again?
Technology. Richard, are you able to call him?
I'm recording, yes, but I tried to reach Jeff, but he didn't pick up his phone, so I'm just texting him now. I asked him to kind of log on and then log off and then log on again, but I don't see him.
It must be the effect of the hothouse earth effects.
Probably, but let me just text him. Let me just see if he's still here.
Ishi Fang, I like your t-shirt. Stand up again. Show us your t-shirt. Yes.
Oh.
Oh, San Francisco. Okay.
Okay, Jeff is joining again.
Okay.
So let's see. Where are you? Okay. Jeff, can you hear us? All right, but we can't hear you. You're mute. Can you unmute?
There's some problem with his microphone.
Yeah. We can't hear you, unfortunately. You're still on mute.
I'm not muted.
Can you text him?
I have already texted him.
Oh, okay.
Hello, can you hear me now?
So
He's a little bit, I think there's
Perhaps you could ask him to test his video, the computer audio. If you could just message him.
He's doing that.
Yeah, okay.
Sometimes you reboot and restart. If I help, reboot and restart.
Yeah, so therefore I asked him to log off and then sort of
Log off and log in completely.
Yeah.
Sometimes you have to even close the computer and then restart.
Actually, I can hear Jeff. It's just that his volume is extremely soft.
Yeah.
Then you turn on his my volume then.
Any better now? Hello?
Yes, now.
Oh, yes.
Yeah?
Yes.
Yeah.
Sorry. I don't know why. I was not muted. I think it was my computer system. I do apologize.
I think I have the same problem, but I started early, unfortunately. So wonderful, Jeff. That's great.
Okay.
So I made you co-host. Let me just double check if it's still there. You are co-host, so you can share slides if you have.
I shall, indeed.
Perfect.
Are you able to see my screen?
Not yet.
Yes.
Coming?
You have to share.
You can see? Oh.
Nope.
I am sharing. What about now?
Coming.
Yeah, now it's coming.
It's, yes?
Yeah, excellent.
Okay.
That was a little bit of a shaky start. I do apologize. And thank you very much for inviting me to speak to you this evening. I hope you can hear me loud and clear.
Yes.
Yes.
And special thanks, of course, to President Dinesh and also to Bridget and Suresh as well. And happy Deepavali to everyone.
Oh, sorry.
So if it's okay, I will continue. Time is ticking on. It's now about 10 to 8. Perhaps I should make a start. Yeah? Okay, so the title of my talk is Climate Change. Can we avoid something called a hot house Earth? This is a reasonably new term that's being used in climate change, and it's really to serve as a warning about the potential impacts of climate change. So in my talk, I'll talk about the Earth and what we call its natural greenhouse effect, and the definition of a hothouse Earth, and also something called the Earth's energy imbalance, which is really a very specialized branch of climate change science, which is so important to our understanding of what's happening with our planet. I'll also be mentioning some tipping points on what we call irreversible climate change. It sounds a little bit frightening. I'll explain that. And also about how we basically solve climate change through the adoption of what I refer to as negative emission technology. And lastly, I'll mention something called geoengineering. So I am a scientist and I am an engineer, and I work with a lot of numbers, but I'll try and keep it quite straightforward. Some of the numbers that I'll be mentioning include the number 2, number 1.5, another number 1.1, slightly bigger number 415, 415. Sounds a bit like bingo already, doesn't it? Another figure is 0.87, a slightly bigger number 520,000, and then we have a very large number. This is 358 sextillion, or a billion times a trillion. Another rather large number is 420 billion, and then we have a number lower, 350, and last of all we have a number 1. Yeah, does that make sense?
No.
So this is a picture of our planet Earth from space. This picture is often referred to as the most influential photo of all time. And it was taken in 1968, actually on Christmas Eve, as the Apollo 8 mission space rocket was coming behind the moon and took this picture called Earthrise, basically showing the vulnerability of our planet from space. And really, scientists like myself often ask the question, so why is our Earth different? Why is it not just a ball of dead rock floating in space? And what we do know, of course, is that our solar system was formed about 4.5 billion years ago, when gas clouds condensed to form a star, our sun, and the planets in our solar system. Earth is, if you like, the third rock from the sun. And as far as we know, of course, the Earth is the only planet that contains life in our solar system, if not the galaxy, if not the universe. Although it's unlikely, but as far as we know, it's the only one that has life on it. So in particular with climate science, we're interested in what's happening to the Earth's atmosphere as part of the climate system. So of course, I'm referring to the thin envelope of gases around the planet. And in terms of scale, if you imagine a football with a postage stamp stuck on that football, that's about the size of the atmosphere relative to the planet Earth. So it's a very thin layer and very interesting composition. It has a mixture of gases in what we call a disequilibrium, or a non-steady state. So gases like methane and oxygen are present together, which is a bit of a challenge to understand without understanding the presence of life on the planet. So we have a tightly coupled system which shows evidence of temperature regulation. So the Earth and the atmosphere interact together to form this system. And that's really due to the presence of what we call greenhouse gases in our atmosphere, which I'll come back to in a moment. We also know that the chemistry of the atmosphere has a very strong interface with the presence of life on the planet, biodiversity. And this is the area that I work in. It's a branch of science called biogeochemistry. One example of that, of course, is what basically plants do, vegetation does on the planet. And for those of you who remember your school biology, you'll know that plants take up carbon dioxide and give out oxygen, which of course we use for respiration. And when plants die, they become dead organic carbon, and over geological time, they form the fossil fuels, coal, oil, and gas. So it's quite interesting fact that our modern economy, our modern civilization, is actually based upon dead organic material from millions of years ago, which essentially we burn to create energy. And when we do so, we do the opposite of photosynthesis. We consume oxygen for combustion and generate carbon dioxide. So we've got this very interesting interplay, if you like, between photosynthesis and respiration on the planet. So we refer to something called the Earth's natural, and I stress the word natural, greenhouse effect. So in fact, the greenhouse effect is not entirely man-made. We have an important natural greenhouse effect on the planet. And many of you, I'm sure, are familiar with a greenhouse. And basically, the greenhouse works by trapping heat from the sun. And the panels of glass let in the light, the heat, and keep longer wave heat from radiating back to the environment, keeping the greenhouse warmer than it otherwise would be. The greenhouse effect on the planet works in much the same way as the greenhouse that you can see here. So energy arriving from the sun in the form of visible light and shortwave radiation, the gases in the atmosphere trap heat just like the glass in the roof of the greenhouse. This is what we call the natural greenhouse effect, and the heat trapping gases involved include carbon dioxide, water vapor, gases like methane and nitrous oxide. All of these gases have a very strong interface with biological processes on the surface of the planet. So if we take 1 million molecules of air in our atmosphere and look at them carefully, we'll see that nearly 800,000 of those molecules are nitrogen, which is a fairly inert gas. Just over 200,000 molecules are oxygen. Thank God, we'd be pretty stuck without oxygen. So thank goodness for oxygen. But the gases highlighted in yellow are the greenhouse gases that keep the Earth much warmer than it would otherwise be. So we have just under 4,000 molecules out of that million of water. And before we started burning fossil fuels, we had about 280 parts per million of carbon dioxide and just about 1 part per million of methane in the atmosphere. Now, the interesting thing here is that those gases cause a warming on the surface of the planet by about plus 33 degrees centigrade. That basically means without those greenhouse gases, Singapore would be about freezing point. And the average temperature on the planet would be about minus 15 degrees centigrade. So these gases are absolutely essential for life on Earth to continue as we know it today. It's now almost 200 years since the French physicist Joseph Fourier described the natural greenhouse effect. And it was the mid-19th century when the Irish physicist John Tyndall showed that water vapor and other gases create the greenhouse effect on the planet. So we've known about the greenhouse effect for a long time. At the end of the 19th century, a Nobel Prize-winning Swedish chemist, Sven Arrhenius, calculated that if mankind burned all of the coal on Earth, it would enhance the greenhouse effect and increase the temperature of the planet by several degrees centigrade if the atmospheric carbon dioxide was doubled. So the history of knowledge of climate change is over 100 years old. Simply put, adding more of these greenhouse gases to our atmosphere enhances the natural greenhouse effect. In 1979, just over 40 years ago now, the world had its first climate change conference in Geneva, Switzerland, and that led to the formation of the Intergovernmental Panel on Climate Change, for which I'm an expert reviewer, as was mentioned at the beginning. About 10 years later, in 1990, 30 years ago now, the IPCC reported that human CO2 emissions, mostly associated with fossil fuels, were responsible for over half of the enhanced greenhouse effect being observed at that time. Now, of course, that was 30 years ago. A lot has happened since then. So these numbers in red represent the addition of additional concentrations of greenhouse gases for water, carbon dioxide, and methane that we now hold responsible for human or anthropogenic climate change. It was in 1992, again almost 30 years ago now, that the United Nations came together under a framework convention and stated that humanity must achieve stabilization of greenhouse gas concentrations in the atmosphere at a level that prevents, in their words, not mine, dangerous anthropogenic or human interference with the climate system. This was really the beginning of concern about the impact that humankind was having on the climate. At the time, this was widely interpreted as a 2 degrees centigrade increase in global mean surface temperature, or an atmospheric concentration of around 450 parts per million. So before we started burning fossil fuels, we had a level of about 280 parts per million. Unfortunately, since 1992, scientists like myself have realized that the 2 degrees centigrade target is not really based upon good science. So we have a wealth of new scientific data from global observation systems like satellites, and also records from the planet itself in terms of environmental chemicals and the study of ice cores, which tell us that the planet today is unfortunately already experiencing dangerous climate change, even at 1 degree centigrade of warming above the pre-industrial baseline. So this has created a lot of concern about the 2 degrees centigrade target. I'll come back to that. So what we do know about carbon dioxide in our atmosphere is that it is the main greenhouse gas that is driving climate change and regulating the Earth's surface temperature. So we're talking about an enhanced natural greenhouse effect, mostly through the burning of fossil fuels and land use change, deforestation, the removal of trees which suck out carbon dioxide from the atmosphere being a good example of that. So if we look at this chart, it's actually derived from the big island of Hawaii, which I was very fortunate to live upon for a few years. It's a beautiful place to go. I do encourage everybody to visit, put it on your bucket list. But what this graph shows is the relentless climb in our atmosphere of carbon dioxide concentrations from the year 1958. We have a seasonal oscillation shown on this graph here, these are up and down lines, but you can see this steady increase in our atmosphere. In fact, human activities have raised the concentration of CO2 since the middle of the 19th century by 47%. We're now at a concentration of 415 parts per million in the atmosphere, and emissions have gone up by 60% since the UN Framework Convention in 1992. That's a big increase. In fact, when we look at the Earth's climate history, we know that we now have the highest level of carbon dioxide in our atmosphere for at least the last 800,000 years, possibly the last 65 million years, and the rate of increase of CO2 in the atmosphere is about 10 times faster than any period that we've recorded in the Earth's climate history, something that we call paleoclimate. So we can look back in time and actually look at the record and compare today with previous times. So it's carbon dioxide which is driving climate change, excess carbon dioxide in our atmosphere. And here we see the temperature record from 1880 up to the present. And basically we have elevated global surface temperature by about 1.1 degrees centigrade compared to a pre-industrial baseline, which is normally measured between 1880 and 1910. That may not sound like very much, but according to the United Nations World Meteorological Organization, the 20 warmest years on record have all occurred within the last 22 years. And in fact, the last 5 years just gone have been the warmest ever. The September that's just gone, September 2020, has been the warmest September on record, plus 1.25 degrees centigrade. So this is disturbing. And again, if we look at the Earth's climate history, we know that the last time that the Earth was this warm was during the last interglacial period, a period of time about 126,000 years ago. And at that time, sea level was between 6 and 9 meters higher than it is today. In fact, if we go back further in time to the mid-Pliocene, between 3 and 4 million years ago, CO2 concentrations were similar for different reasons. Obviously, we didn't have mankind and industry then, but sea level was up to 30 meters higher than today. So if you superimpose those types of sea level rise on an island state like Singapore, then obviously the implications are very serious. That's basically where we are. So this led Professor Will Stephan and colleagues a couple of years ago to publish their work in the Proceedings of the National Academy of Science. And that's when the term hothouse Earth was defined. So basically what Professor Stephan said was that higher atmospheric temperatures caused by greenhouse gas emissions could push the climate system across tipping points. And these are basically points in the climate system which trigger the release of carbon that is naturally stored in global ecosystems on our planet, in forests and in frozen soils that we call permafrost. These are massive reservoirs or banks of carbon which can be released as the planet becomes warmer. And the authors noted that we can get a cascade, multiple tipping points, which would very likely take the trajectory or the direction of the Earth system out of our control, out of human control, and to a much hotter condition known as hothouse Earth. So this is where climate change really takes on a life of its own and becomes irreversible. So basically, if we push the system too much with our greenhouse gas emissions, then stored carbon within the Earth system means that climate change becomes an unstoppable train, if you like, irreversible. So this underlines the importance of controlling greenhouse gas emissions. So you may have noticed a lot in the news, particularly last year, this year, we're experiencing major forest fires across the planet in California, record-breaking fires, also in Australia. The Amazon, often referred to as the lungs of the planet, of course, record-breaking fires across Brazil. And of course, these fires add carbon dioxide to the atmosphere. So as the atmosphere gets warmer, the risk of further fires increases. As we have more fires, we have more CO2 released, and this becomes what we call a positive feedback, leading to a tipping point. Positive is not good in this sense. this is where we can push the climate system such that climate change takes on a life of its own. The picture here is just showing frozen soil, permafrost in Siberia, where again the melting of this soil releases carbon into the atmosphere. More carbon becomes warmer, more carbon is released. In fact, in permafrost shown here, there is at least double the amount of carbon than what we have in the atmosphere. So as we warm these reservoirs and release carbon, the danger is that climate change becomes uncontrollable. Obviously a situation where we want to avoid. Okay, so this slide basically talks about the energy balance of the planet. So here you can see sunlight coming into the planet and how heat is released from the planet. So in order to have a stable climate, we must have an energy balance. Basically, the energy coming into the system must equal the energy going out to space. This is really the basic physics of the climate system. So currently, of the incoming solar radiation, about 70% of the energy is absorbed by greenhouse gases and then re-emitted to space. So if you like, adding more greenhouse gases to the atmosphere, it's a little bit like throwing an extra blanket on the bed. If you do that, the bed will get warmer and then start radiating energy out to the room. About 30% of the incoming solar radiation is reflected back out to space by what we call high albedo surfaces. So a very good example of that is ice. So at the top and the bottom of the world, we have ice in the form of polar ice caps, which reflect a lot of that energy away. So basically, if we know the Earth's energy balance, we can understand the future direction of climate change. And this is really the cutting edge of climate science today. And what I wanted to show you was some new research that has just been published in September, just gone, by Schuckman and his colleagues. And basically, they have done an excellent job of looking at the energy imbalance, which leads to the accumulation of heat in the Earth's system, in our atmosphere, in our ocean, in the ice sheets, and on the land. And this graph here really shows very well the accumulation of heat in the Earth's system over time. The record started in 1961, and what this is showing us is that the vast majority of the heat is being stored in the ocean. In fact, 90% of the excess heat is being stored in the ocean. The land and the ice comprise about 9%, and the atmosphere is only responsible for about 1% of the heat accumulation. So the 1 degree centigrade of atmospheric temperature increase that we've seen so far is only 1% of the heat gain in the Earth system. Most of the energy is going into the ocean. In fact, we can put a number on this. The total energy gain since this record began in the 1960s is 358 zetajoules. And this is where this big number comes from. So 1 zetajoule is 10 with 21 zeros after it. So it's a pretty big number. And understanding this imbalance in the Earth system, basically more energy coming in than is being re-radiated back out to space because of the excess greenhouse gases in our atmosphere, is really the best metric we have in terms of understanding where we're heading for with climate change. What it in fact means is, even if we do not add any more greenhouse gases, the Earth will carry on warming until it restores the energy balance in the system. So what I said was that most of the heat is accumulating in the ocean, and that a stable climate requires energy balance on the planet. It's only quite recently that we've been able to measure the ocean's energy imbalance. And we do that by measuring the heat content in the ocean. So as I say, most of the incoming solar radiation is absorbed by the ocean. Again, thank goodness. The temperature increase that we've seen in the atmosphere is only 1% of the heat accumulation. So if we can measure the ocean's heat content, we can really get a definitive measurement of the physics of global warming. Now, it's only fairly recently that we've been able to do this, really since 2005. So the last 15 years, we've been fortunate to have what we know as the Argo Float Global Observation System. This is very important to our understanding. What you can see here in this picture is an Argo float. So it's about the size of a man. You can see a couple of guys standing here. Here's one of the floats, and here's one of the floats in the ocean. We now have a system approaching 4,000 floats across the world's oceans. So each one of these dots is an Argo float. And basically what these floats do, remarkable piece of technology, they will duck down into the ocean, sink into the ocean down to 1,000 meters and drift in the ocean for about 10 days and then go down to 2,000 meters, 2 kilometers below the ocean surface, and then they will rise over 6 hours, taking measurements as they rise, including temperature, and eventually they pop up at the surface and beam their data to a satellite. So this gives us a near real-time measurement of the heat accumulation in the ocean. So it's a fantastic piece of technology that we've had since 2005 to measure the heat content in the ocean. So what does this data tell us? Well, here's the record. In fact, the record goes back much further than 2005, all the way back to the middle of the last century, where we use ship-based data of temperature measurements to estimate the heat content in the ocean. As I say, since 2005, we've had the data from the Argo float system. And as you can see here, the heat content in the ocean has been rising steadily, particularly since the late 1980s. So what this data set shows us from Argo is that indeed the Earth is out of energy balance. The Earth is accumulating more heat than is being radiated back out to space. And this is the driver of climate change. In fact, last year, it was reported that the ocean heat content in the upper layers of the ocean was the highest ever recorded. And this led the IPCC to state, basically without doubt, unequivocal, with a 99% certainty, that indeed the Earth is warming. And unfortunately, the rate of warming is accelerating and intensifying. We now have very good data on this. In fact, we can measure the heat accumulation across the planet in terms of watts of energy being accumulated for each meter squared of the planet's surface. And what is basically shown is that we have an energy imbalance of about 0.87 watts of energy per meter squared of the planet's surface. That sounds like a very small number, but when we do the maths on this, it means that we have more warming in the pipeline. So as I say, even if we stopped emissions today, the Earth would carry on warming because of the energy imbalance. That comes out at about an extra 0.65 degrees centigrade of warming on top of the 1.1 degrees centigrade of warming that we've seen so far. We can actually calculate the significance of that. So essentially what it means is that every day the Earth system is accumulating energy, and that's equivalent to the detonation of over 500,000 Hiroshima-sized nuclear detonations each day. So if you can imagine detonating that number of Hiroshima-sized nuclear weapons, that's the amount of energy that the Earth system is gaining each day through the excess of greenhouse gases in our atmosphere. Huge number. We can also calculate what the overburden is of carbon dioxide, this driver of excess warming, in our atmosphere is. And we now have an excess burden of carbon dioxide in the atmosphere of about 57 parts per million. So for us to restore climate and stabilize the climate and prevent further warming, essentially this is the amount of carbon dioxide that needs to be taken out of the atmosphere to restore energy balance. So the energy imbalance on the Earth must be zero. Now, these are interesting numbers. Another number here is that 1 part per million of carbon dioxide in the atmosphere is the equivalent of 17.3 billion tons of carbon dioxide. So this figure of 57, we need to multiply it by this number. That's how much carbon dioxide we need to remove from our atmosphere to take the energy balance back to zero. So of course, given these numbers, the world got very concerned about this 2 degrees target number that I mentioned earlier. And the world came together under the Paris Agreement at the end of 2015 and agreed to hold global temperature increases to well below 2 degrees centigrade compared to pre-industrial levels, basically before we started burning fossil fuels, and endeavor to limit the rise to no more than 1.5 degrees centigrade. Remember, I said that already we're at 1.1 degrees centigrade, and we have about another 0.65 degrees centigrade in the pipeline, which means that we're going to blow straight past 1.5 degrees centigrade. A few years later, in 2018, the IPCC released a report, Global Warming of 1.5 degrees centigrade, where basically they gave a warning that human-induced warming of the atmosphere is already having an extreme impact upon our climate system with respect to extreme weather events, storms, heat waves, floods, and fires that I mentioned earlier. This together represents a severe risk to global ecosystems, such as coral reefs and forests, many of which are very important in terms of storing carbon, as I mentioned earlier. I hope everybody's following. I'm trying to get some. Okay. So the IPCC basically said that limiting global warming to no more than 1.5 degrees centigrade requires, in their words, rapid, far-reaching and unprecedented changes in all aspects of society, a very clear warning from the IPCC. So the challenge of staying below this target of 1.5 degrees centigrade is very necessary and very desirable in order to avoid dangerous climate change, or indeed a hothouse Earth. So major reductions in greenhouse gas emissions are now essential. In fact, the IPCC put a number on this, and they said that basically to have a 67% chance, a 2 in 3, or what I call a 4 in 6 chance of a good outcome to limit warming to 1.5 degrees centigrade, the amount of carbon that we can release into the atmosphere, our carbon budget, as of January 2018, so almost 3 years ago now, was 420 gigatons. That's a big number. So that's 420 billion tons. But each year we're releasing about 40 gigatons. So global warming may reach 1.5 degrees centigrade as early as 2030. So that figure, 67% chance or 4 in 6 of a good outcome, is a very interesting number to me. I like to compare it to the game of Russian roulette, where we put a single bullet in the chamber of a pistol, spin the chamber and pull the trigger and see what happens. Of course, in that scenario, we have a 5 in 6 chance of a good outcome. So this figure of 420 gigatons is slightly less favorable than Russian roulette. So fairly serious consequences if we don't meet this target. So the IPCC has told us that in order to limit warming to 1.5 degrees centigrade under the Paris Agreement, then emissions must really peak by this year, no later. They must fall by 45% by the year 2030, so less than 10 years from now, and the world must reach net zero carbon emissions by the middle of this century. That's a big ask. That's a tall order. So the question is, can we avoid a hothouse Earth? And the good news is, yes, we can. But what we need to do is restore the Earth's energy balance. This fellow here is James Hansen. He first warned the world about dangerous climate change in the 1980s. He's the former chief atmospheric scientist, he's retired now, of the Goddard Space Institute at NASA in the USA. Very knowledgeable gentleman. Basically what Professor Hansen has said is that by restoring the Earth's energy balance, we need to return to an atmospheric concentration of carbon dioxide of no more than 350 parts per million. So if you recall, I said we need to take out about 57 parts per million of carbon dioxide from the atmosphere. Excuse me. So the area that I work in as an engineer and scientist is really focused on how we can achieve this. So increasingly, the IPCC and the international community is talking about something called negative emission technology. And here we see one example called bioenergy with something called carbon capture and sequestration. So really here we're relying upon the power of nature again. So I talked about photosynthesis, capturing carbon, and long-term production of fossil fuels over millions of years. This is an attempt to short-circuit all of that by growing trees and biomass, crops, which we can then burn. We can burn the biomass to produce energy. And then when the carbon dioxide is released through the combustion of that biomass, we essentially capture that biomass and bury it. We can actually produce some useful products along the way. One of those products is known as biochar, which is a soil fertilizer. So it can help us increase soil fertility, improve food security, and enhance the storage of carbon in soils. So I think this is one massive opportunity for a country like India, for example, which has a very high dependence upon agriculture and a rapidly rising emission of carbon dioxide. So if we can learn to capture this carbon dioxide and improve soil fertility and enhance food security, then we begin to reduce our carbon concentrations in the atmosphere. So it's really smart thinking. So that's what we call BECCS, biomass energy with carbon capture and storage, or sequestration, as an example of a negative emission technology. Certainly going to be hearing much more about that. The other area that I work on, we refer to as direct air capture. And basically what you can see here are a bank of very large fans, which are basically sucking air through and stripping the carbon dioxide out as the air passes through the system into a carbonate solution. And what comes out the other side, excuse me, go back. What comes out the other side is air that's been stripped of its carbon dioxide. So there are actual projects that you can see here, for example, in Switzerland. We have other projects in Canada and also a system in Iceland where this technology is being tested. It's quite remarkable. So from this captured carbon, we can now actually make renewable fuel. We can create chemicals which are much more sustainable than fossil fuels. Currently, this technology works out at about $200 for each ton of carbon dioxide that's removed from the atmosphere. Remember what I said, that just removing 1 part per million of carbon dioxide represents many billion tons of, trillion tons of carbon dioxide. So it's a very expensive technology at the moment, but there is a lot of investment going in here to reduce the cost of this technology. Now, unfortunately, it looks as though this technology is not going to come online rapidly enough to help us with the energy imbalance that I've spoken about. And it's a very serious energy imbalance. And this is where you may hear the term geoengineering. So this is another area that I get involved with. Basically, it's an attempt to restore the Earth's energy imbalance. One of the types of geoengineering that you may hear about is something called solar radiation management. This is basically where we put mirrors in space. It sounds crazy, I know, but it may come to this because of the excess incoming solar radiation from the sun. The idea is, of course, that we put mirrors in space to reflect energy away from the planet and to cool it down. Another form of solar radiation management involves mimicking what volcanoes do. So basically, when a volcano erupts on the surface of the planet, it releases a huge amount of particles into the atmosphere, and these particles reflect sunlight away from the planet. And that actually cools down the planet by 1 or 2 degrees centigrade for a major emission for maybe 1 or 2 years. What you can see here in this photograph is a ship which has been designed to sail across the ocean, and as it does so, it sucks up seawater and sprays that into the atmosphere. Those tiny particles of salt that you can see coming out of the chimney stack help to reflect energy away from the planet, cooling the planet down. These are the types of technology that are now being investigated as part of geoengineering. So solar radiation management is one solution. Another solution that I've worked on...
Professor, sorry, I hate to interrupt, but we are already past 8:30, and
I think...
Yeah, I'm on the last slide.
It's really, I think we could go on and on, but I think we need to wrap.
I'm on the second to last slide.
All right, okay.
Yeah, okay. So the other type of geoengineering is climate restoration, something called nature-based solutions. And basically what we're looking to do here is enhance photosynthesis to draw down carbon from the atmosphere. So what you're looking at here is pictures of very tiny plants in the Earth's oceans that we call microalgae or phytoplankton. And basically feeding those plants with iron triggers algal blooms. You can see one here, hundreds of kilometers across. So as these plants grow, they suck carbon out of the atmosphere, and when they die, they take that carbon to the bottom of the ocean, reducing the amount of carbon in the atmosphere. So great technology. So final slide then, climate change, avoiding a hothouse Earth. So the key points, the take-home points are, number one, that dangerous climate change is already here, even at 1 degree centigrade of warming. So in order to avoid a hothouse Earth and triggering tipping points with severe ecological and economic risks, we need to rapidly decarbonize the global economy and restore the Earth's energy imbalance using negative emission technologies. For example, BECCS and direct air capture. The cost of doing this is immense. The IPCC estimates it requires an expenditure of up to $150 trillion by the middle of this century. However, the cost of doing nothing in terms of the damage that unmitigated climate change is projected to cause is up to just under $500 trillion. So those are the numbers at play here in terms of the damage and the cost of mitigating climate change. So if these things do not work, negative emission technology then we're really looking at geoengineering with very unknown ecological impacts in terms of the integrity of the planet. So I'll just, with that, say thank you. The last number on my list of numbers, of course, is number 1, as in we only have one planet. There is no planet B, and that's what we need to look after. So thank you.
Thank you. Thank you, Professor Jeff.
Sorry for going slightly over time. Just on time.
Thank you. I think the good news is there is a solution to stop this catastrophe. Anyway,
Yes.
we have no
Quite expensive,
time.
but
Is expensive. We have not much time, so there will not be any time for questions and answers.
Can I ask?
Can I ask Professor?
Sorry, President.
Yeah.
We have 2 questions here. Can I basically connect, Professor? Can I connect the 2 gentlemen from our members to you directly via email?
Bridget, can we ask Professor to stay on, and we close the meeting, and then we can, whoever wants to ask question can stay on.
All right. Okay. Okay.
Professor, would you like to stay on for some time?
no problem at all. My pleasure, yes.
Thank you very much. So I will now ask past President Stan Lowe to give a vote of thanks.
President Dinesh, fellow Rotarians, and Zoom participants, it is my privilege to propose a vote of thanks to the speaker today. Frankly, Professor Jeff Obat, your talk is very depressing. Very depressing. Anyway, I remember some time ago when I was a young engineer, we were talking about the Montreal Protocol in 1987, and it was to stop the depletion of the ozone layer. But through international cooperation and efforts by everyone, we are seeing a reduced size of this hole, the ozone layer hole. So we are moving towards some success. And I'm sure we can, again today, to solve this hothouse Earth problem, but it has been done through international efforts and cooperation. And I think like the Montreal Protocol to stop ozone, I think we can also solve this problem because we have no other choice.
That's correct.
So ladies and gentlemen, let us now unmute our Zoom, so we can properly show our appreciation to our speaker, Professor Jeff Obat. Jeff, thank you.
Thank you.
Thank you. Jeff, can you please stop sharing your screen?
Yes, please.
Yes.
And we can
Thank you, Bridget.
see everybody on the panel. Excellent. Thank you very
I
much.
think please, Professor Jeff will stay on, and I would like those who want to ask some questions, please stay on. Next week's speaker is Mr. Christian Westbell, General Manager of Raffles Hotel. Topic to be advised. And this weekend is very interesting. 14th of November, we have a Diwali. So I would like to wish everyone happy and prosperous Diwali and a great year ahead. Diwali is becoming a universal festival of joy and happiness, lights. So it's for everyone. Of course, we Indians is very most important festival. So I wish a happy Diwali weekend. Thank you very much. And with this, I think I'll close the meeting, and please stay on for the fellowship, and Professor Jeff will stay on with us and we can ask questions. Thank you, and close the meeting and we can start the fellowship. Thank you.
Thank you. Happy Diwali.
Yeah.
Happy Diwali, exactly.
Happy Diwali to everyone.
Thank you.
So
Yes.
we do indeed have, we have Uttam and Vinit with 2, I think, very, very valid questions. Who wants to start? Uttam?
Yeah, sure. Thank you, Professor. That was a rather scary topic. it certainly highlights some of the situations we would be facing in the future. But one of the concerns I have is that there are countries such as the USA who have kept away or got out of this Paris Accord. And I'm hoping that the successor to the current president in the USA looked at this topic a lot more seriously. But do you think if the USA and other countries decided to stay away from this, how effective would the decision be to stop global warming?
Yeah, I think that's an excellent question. First of all, I'm sorry that my talk was a little bit depressing. The numbers are indeed depressing, and the situation is changing very quickly. I think from a political perspective, we've been through a very difficult 4 years since the Paris Agreement, and I think we all know that the United States withdrew from the agreement, and officially it stepped out of the agreement on the 4th of November this year, just after the election. The good news, of course, is that the President-elect Biden has pledged to rejoin the Paris Agreement, and the US, we hope, will take a leadership position in mitigating climate change going forward. The physics and the science tells me that time is very short for the reasons that I outlined. Basically, what the IPCC is saying is not only do we need to be at zero carbon emissions at the very latest by mid-century, 2050, but in addition, we need to now remove the overburden of carbon in the atmosphere using some of the techniques that I described. So I think given the new optimism politically under the Paris Agreement, with the US taking a leadership position, we're going to see a revolution in terms not only of clean renewable energy generation, and it's already on a good trajectory, solar, wind, for example, but we're also going to see major developments in carbon capture and nature-based solutions, including hopefully the reforestation of much of the world's forests that have been lost. So I think there is hope. Personally, I have to be very careful. I am an ambassador for the Youth Council in Singapore. So I gave you the unsweetened version this evening. So I have to caveat what I say to our youth. But I think at the same time, they are the source of hope and inspiration, not only in Singapore, but across the planet. So we are seeing a great movement across the planet, youth stepping forward and demanding that we, the grown-ups, do something to address climate change. So that does fill me with hope.
Thank you.
Thank you. Thank you so much. Vinay, you had another question as well, right?
Yes. Hi, Professor Robert. Thanks for a very insightful talk. Some of the numbers I really liked. I mean, I like the fact that this wasn't just about a chart with things going up, and it had numbers, it had a clear idea of what needs to be done. Given the current political situation, not just in the US, but the fact that places like China and India have limited options to really move away from some of the more traditional fuels, if we do nothing, or if we do maybe 20% of what needs to be done, how much time do we really have? How long? You mentioned a tipping point, which I found very fascinating.
So you're ready for the really depressing news. This is a question that keeps me awake at night. And really, looking at the very latest science, then there is evidence to say that we're already crossing tipping points at 1.1 degrees centigrade of warming. I showed the examples of the forest burning. These seem to be getting worse in terms of their severity and frequency. And in particular, what I didn't have time to show was the degradation of the world's ice sheets. I'm sure you've all heard about the degradation of the Arctic floating sea ice, and increasingly Greenland and the Western Antarctic ice sheet as well. The very latest evidence tells us that these ice sheets are disintegrating in a highly non-linear manner. So the projections by the IPCC are looking increasingly conservative. So I think it's absolutely vital that we move to zero carbon emissions as rapidly as possible. There has to be a major increase in the amount of investment into research for nature-based solutions and direct air capture. So we are flirting certainly with tipping points. And the longer that this goes on, the more difficult it becomes to turn it around. Okay. I mentioned the paleoclimate evidence, which is particularly worrisome, particularly in terms of sea level rise. And the good news is that Singapore is aware of this. You may have heard our Prime Minister talking about sea defences to protect against sea level rise. So there's a lot of good anticipation in wealthy countries like Singapore. But what about our friends in the region? What about developing countries? Now, India, again, is rising rapidly in terms of its carbon emissions and its ranking, although I think it's done an excellent job on developing renewable energy at the same time. I think there are major opportunities for India in terms of cutting carbon emissions from agriculture. And the best thing that any developing country can do is just completely phase out coal. Coal is the most carbon intensive form of fossil fuel, and by leapfrogging coal and going straight into renewables, then carbon emissions can be reduced quite drastically. So I think that has to be the emphasis, and I think the developed world has an obligation to invest under the Paris Agreement, under a Green Deal that we keep hearing about, to help developing countries bypass fossil fuel combustion for energy generation.
Can I jump in on one of those points as far as India is concerned? One of the major sources of energy there is coal, and if India is to withdraw, if you like, the entire coal production over the next few years, how are they going to be able to replace that with renewable energy? It's a rather expensive proposition. And will the developed countries support their efforts?
Well, I think they have to. So I deal with the physics and the science. I'm not so strong on the politics and the diplomacy. Do I have great faith in the world reaching coordinated, intelligent, swift action on this problem? You know, the last 4 years of global politics tells me probably not, although I think there is growing optimism now. Personally, this is why I work on negative emission technologies. And I tell my students, if I were to go to Delhi or Beijing and tell a person on the street, sorry, you cannot have your car, you must stay with your bicycle because of global warming, then you can imagine the sort of reaction that I would get, right?
They'll send you back.
So, you know, yeah, everybody deserves their place in the sun. So to deny development in a country like India, I think is wrong. But at the same time, we are now clashing with the physics of the problem. So this is why negative emission technologies are so important. Basically, to allow humanity, civilization, if you like, to continue doing what it does in terms of growing its economy, but not taking us to tipping points where we have too much carbon in the atmosphere. So I think India has a great role to play in terms of nature-based solutions, for example. So restoring forests, restoring mangrove, restoring soil carbon reservoirs through better agriculture, recycling animal wastes. All of these things are important. But I think the world should invest in India to avoid development of coal-powered energy generation as much as it can.
I agree.
I mentioned nuclear, of course, but yeah, all of these things.
There's Suresh Hatiramani also has a question. I mean, I need to stop at 9 o'clock because I have another call.
Of course.
So I'm the host. I will hand it over to someone.
Yeah, okay.
Suresh.
Professor, thank you very much for a most enlightening talk. You kind of partly answered my question, and my question is this, that why would a country, I mean, I can understand interest groups in climate denial, you know, because of financial reasons or specific reasons, but why would a whole country like the US withdraw? I mean, I can understand it was a one-man decision, but the whole country for 4 years acquiesced in that decision and did nothing about trying to bring the US back into the Paris Accord. What would prevent a similar thing happening with India or China completely withdrawing because of their own narrow interest? I mean, is there any mechanism whereby you can prevent such an occurrence in the future?
I think that's a very excellent question. I think the US was very dogmatic about it. We don't have to get into those reasons. They claimed it was unfair on the US and it would have an unfair financial burden and affect the American way of life, if you like. The opposite side of the coin, of course, is that sustainable green technologies are seen to be one of the massive economic opportunities of this century. I think I mentioned that in my last slide to some extent. So when we look at the renewable energy markets, solar, wind, geothermal, they're escalating very quickly. So there's a lot of investment going in. That's where the opportunities are. That's where the job growth is. And now we hear about green financing, the Green New Deal. So people who are getting on that bandwagon are making money. So it's a win-win situation. The issue for India is that its per capita emissions are still incredibly low. If you look at the history of the contributions of greenhouse gases to the atmosphere, India is not responsible. It's my own country, the UK, it's the US, it's the developed countries. So again, I think there has to be allowance for countries like India, but there has to be a massive injection of technology, a helping hand. Because at the end of the day, as I say, we've only got one planet. And if we go over the cliff into the abyss, everybody suffers. And I think the reality is already in India, we're seeing record-breaking temperatures. People are suffering. It won't be long on this trajectory that we're on before the food supply system breaks down. You know, and I think we have unprecedented heat waves, unprecedented floods in India. So we're all caught up in this. It's very sad that, of course, most people in India are in no way responsible. It's the less fortunate countries in the world who are going to suffer first. And that's true in this part of the world as well, beyond Singapore, our friends in ASEAN. So we have a collective responsibility, and really my job as an engineer is to make it a win-win situation, to make it attractive enough for countries like India to be involved and really develop the economy on green principles. So renewable energy, agriculture, good examples of that. But unfortunately, if the world does not pull together, then the consequences, as I've shown, are going to be very severe. And indeed, the World Bank is saying that if we reach the temperatures that are projected, even with the Paris Agreement, by the end of the century, i.e. 3 or